same idea. So, okay, what we had talked about, just to kind of refresh you a little bit, what we had talked about last time is that the best way to handle a problem like this is just to make our sort of first move in our little chess game to just get rid of these fractions. And to do that, we have got to be able to figure out what the LCD, the least common denominator for all of these fractions are. And oftentimes, so we had looked at a way of doing that that is pretty simple and straightforward. And we'll do that. We'll look at that method, but I'll show you in a minute that a lot of times there's a faster, kind of simpler way to do that. I mean, it's pretty simple either way, but if I write down our denominators, which are 9, 2, and 6, and if I factor those, and by that I mean I break them down as far as they'll go. 9 is 3 times 3, for example. 2 is a prime number, right? The only stuff you can multiply to get 2 is 2 times 1. So other than 1, 2 is the only factor of 2, and 6 is 2 times 3. And so the sort of technical way to find the least common denominator is just to write out, these are called prime factorizations, where you break the factors down all the way to prime numbers, and then take the biggest number of occurrences of each prime factor. So we only have factors of 2 and 3 here. And so if I look at the factors of 2, there aren't any factors of 2 in the number 9. There's one factor of 2, of course, in the number 2, and there's one factor of 2 in the number 3. So no one of those denominators has more than one factor of 2. Then I need exactly one factor of 2. And then when I look at the 3's, 9 has 2 factors of 3. 2 doesn't have any factors of 3. And 6 has one factor of 3. So none of these numbers have more than 2 factors of 3. Then I need exactly 2 factors of 3. And if you multiply all of those numbers that I've circled together, that'll give us the least common denominator. 3 times 3 is 9. 9 times 2 is 18. That's our LCD. Everybody with me? That's pretty simple to do. The other thing you could do, and often this, this isn't always, it always works. It's not always super efficient. But if you have a few denominators and the numbers are small, and when I say the numbers are small, I mean, notice that these numbers, none of them have very many different prime factors, right? Another way to do this is just to look at those denominators. We know that what we want is the smallest number that all of these divide evenly into. Then we know that number has to be at least as big as our biggest denominator, right? 9 won't divide into anything smaller than itself. Not only does it have to be at least as big as our biggest denominator, it has to also be a multiple of that biggest denominator. Because, for instance, 12 is bigger than 9, but 9 doesn't divide into 12. That doesn't help us. So one way to do this that's often pretty fast is look at your biggest denominator, look at each multiple of that denominator until you find the first multiple of 9 in this case that 2 and 6 also divide into. And just to show you how quick and easy that is, 9 times 1 is 9. But of course that won't work because 2 and 6 won't divide into 9. So look at the next multiple of 9, 9 times 2, which is 18. And of course that's what we need because 9 divides into 18 2 times, 2 divides into 18 9 times, 6 divides into 18 3 times. Then 18 is the smallest number that all of these divide into. Do y'all see that? So now, do y'all see that? Okay, so you start with the biggest denominator. You look at each multiple of that biggest denominator until you find the first one that your other denominators also divide into evenly. Everybody with me? Okay, once we find that least common denominator, it is true that there is a way to restate this equation so that each fraction has 18 for its denominator. And you could do that and you can solve the equation that way. But it is easier, it's simpler just to get rid of these fractions, and we can use the least common denominator to do that. What I need to do is multiply both sides of the equation times that least common denominator, 18 in this case. So let's start with the right-hand side because that one's going to be quicker and easier, and I'm a procrastinator and I like to do the easiest stuff first. So here's what I would recommend. If you are great at working with fractions, then you may already know, you may be off and running at this point. But if you don't feel like you're totally great with fractions, my advice would be, if it helps you look at it this way, let's just say that 18 is the same thing as 18 over 1, right? That just makes it look like we're multiplying two fractions. It might make it look a little better. And so here's what we know about multiplying fractions. It's super important that you get this, okay? So everybody watch real closely. When you multiply two fractions, any factors that are common on top and bottom, you can cancel. And here's what's really going on. Let me come down here and do a little scratch work so I can show you what I mean. So where we've got 5 over 6 times 18 over 1, does everybody agree that 5 over 6 times 18 over 1 is the same thing as 5 over 6 times 6 over 6 times 3 over 1? Here's why I say that these two things are the same. Do y'all see that 18 over 1, remember we talked last week about that when we multiply fractions, all we do is we multiply the two top numbers, in this case 6 times 3, and we multiply the two bottom numbers. Oh, why did I write that 6 over 6? Sorry, let me do that again. And I had a brilliant explanation going and I totally blew it. I mean, at least I didn't say people were eating cats and dogs. Well, I said I wasn't going to talk about any of that, didn't I?
They'll be eating humans next.
Let's just write it this way. Do y'all agree that 6 times 3 over 1 is the same thing as 18 over 1, right? I can cancel these two 6s. The reason I can do that is because if I were to multiply all this stuff, I would have, it would look like 5 times 6 times 3 over 6 times 1 is just 6. But surely we all see that 6 over 6 is 1, right? And so really this is just 5 times 1 times 3, which is just 5 times 3, it's 15. So what we usually just say is, look, we can cancel that common factor of 6 on top and bottom. Everybody see that? Except I typically don't take the time to write it all out like this. I would just say when I look at 5 over 6 times 18 over 1, I would say 6 goes into 6 one time, and 6 divides into 18 3 times, and now I have the number 5 over 1, which is 5, and 3 over 1, which is 3, and so I would, of course, say that's equal to 15. Is everybody with me here? So that's our fraction review. So let's do that. So up here on the right-hand side, when I multiply both sides of this equation times the LCD, 6 goes into 6 one time, 6 goes into 18 3 times, and that's just 3 times 5, which is 15. We're going to do the same thing on the left-hand side, but here's what I want y'all to notice. I'm going to write this out the very long-winded way this time, because if you haven't seen what's going on yet, it'll make you see what's going on. But I won't write it out that way in the future because we're already falling behind in this class, and it's just, we ought to be able to understand how the distributive property works. But if, with that said, here's what I'm going to do. Remember, we are distributing. So we've got to multiply 18 times 2x over 9. Then we also have to multiply 18 times positive 1/2, right? What I'm going to do this time is I'm going to literally write that out longhand. I'm going to write 18 over 1 times 2x over 9 plus 18 over 1 times 1 over 2. So that's what we're actually doing, right? When I do that, we should be able to see that 9 is a common factor of 9 on bottom and 18 on top, so I can cancel it. 9 goes into 9 one time, 9 goes into 18 two times. Well, what does that leave me with? 2 over 1 is just 2, and 2x over 1 is just 2x. So it's just 2 times 2x, which is 4x. Does everybody see that? A lot of silence. You know, an encouraging head nod or something, or maybe a discouraging head shake if you're not getting it. Everybody good here? Okay, we'll move on to the next one. Obviously, 2 is a common factor of 2 on bottom and 18 on top here. And 2 goes into 2 one time, and 2 goes into 18 9 times. Well, that's just 9 times 1, which is positive 9. Remember, on the right side, we've already done that, and we see that 15 over 6 times 18 over 1 is 15. And that's what our problem looks like after we multiply both sides times the LCD. Everybody with me? And of course, from here, we just solve it. Subtract 9 on each side. We have 4x equals 15 minus 9 is 6. And of course, we divide each side by 4. And get x equal, should my final answer be 6 over 4? No, because we simplify that fraction. We cancel common factors on top and bottom, just like we've been doing up here. And so we can say that 2 goes into 4 2 times, and 2 goes into 6 3 times. So our final solution is x is equal to 3/2. Everybody good there? Like I say, I generally don't write this out like we did here because I know that I'm just distributing. I just do it. But what I was going to say earlier is, if it helps you to do this, you should do it. You know, if you get lost in the distributing business, write it out term by term. So we'll take a look at another problem.
Can